Hello, my name is Christopher Wytunick, and today we're going to be talking about aneuploidies and basically what they are, how they're formed, and basically kind of get a good and in-depth idea of how that works. So let's get started with the basic question of basically what is an aneuploidy. An aneuploidy is basically it's an abnormality which is caused by the basically presence or absence of a single chromosome. In terms of the presence, what I mean is it's going to have an additional chromosome located within the zygote, and then what I mean by the absence, of course, is you're going to have a chromosome missing from the zygote, which, of course, if you'd imagine, that would be incredibly detrimental to the offspring of the parents with the problematic and abnormality when it comes to that. So normally cells are in a state which is known as dysony, which is where both chromosomes are just like paired up and they're present. So you just have two pairs of chromosomes present in the cell, and that's basically known as dysony. Now aneuploidies, they can basically come in two different types. You'll have type 1, which I would just call trisomies, and then the other one, which is called a monosomy. I'm pretty sure I'm getting that pronunciation right. So a trisomy is basically where you have two copies of each chromosome, except for one, which will have three chromosomes. So you'll have basically all these pairs of chromosomes, which will have two, just all in two sets, and then you'll have your third chromosome, or your basically your one cell, which has an additional, like chromosome in there, which of course having an additional chromosome within that cell when it should just have a pair causes issues. And then the opposite happens when you have a monosomy, which is basically you're going to have all your cells, like I just said, having two pairs, just two sets, having pairs. And then you'll have your one cell, which will have just a single chromosome in it. Now, each of these types of aneuploidies can be represented almost like by like an equation, I would say. Trisomy can be described as being like 2n plus 1. The n would basically be how many of that cell, which varies. It's basically your exponent. And then the opposite would be monosomy, which is 2n minus 1. So the difference between the two is just the addition or subtraction of that chromosome that would exist in that cell. So now let's get into how aneuploidies actually form and how they happen. So the main location that they take place and that it happens in is going to be the anaphase of cell division. So this can happen in both meiosis and mitosis, but you're really going to have the majority of it happening in meiosis. It very, very, very rarely happens in mitosis. It does, but compared to the rate that it happens in meiosis, very slim amount. So mainly I want to focus on meiosis since that's where we're going to see the majority of it happening, and that's where we focus a lot of our studies on the effects and birth defects that come with having aneuploidies. So basically, as I stated, it's caused in the anaphase part of cell division, and basically the chromosomes will effectively fail to separate. So if you remember from the mitosis videos and meiosis videos, during our metaphase step, spindle fibers go and basically line up, and they basically connect to our X and Y chromosomes, which are on the metaphase plate, lined up in the middle. And then when it goes into anaphase, it proceeds to basically retract those spindle fibers and effectively separate and pull apart those two pairs of the pairs of chromosomes. However, when we have an aneuploidy form, the chromosomes are failing to separate and causing that issue. And this process is known as nondisjunction. And because it can happen in both meiosis 1 and meiosis 2, it gives in meiosis two opportunities for it to happen, while in mitosis it only has one opportunity because, two times anaphase, of course, you're going to have more opportunities for it to cause, which is probably one of the reasons and why it has such a higher rate in meiosis. So I actually have some diagrams here that we can hopefully use to sort of explain what's going on. So we're going to start with meiosis 1. I'm going to try and hold this up to the camera and kind of walk you guys through what's going on. So this is our first cell here. As we can see, we have our spindle fibers connecting to our two cells. The one in yellow is going to be the X chromosome. The one in the pink is going to be our Y chromosome. They're both lined up on the metaphase plate, connected with spindle fibers, the centrosomes down at the ends. Then on to our next step, if we can focus there, it's basically going to pull them apart. But what's happening is you're having both of your X and your Y chromosomes being pulled into one half of that first cell, and you can see that the bottom part of that cell has no chromosomes within it. So what happens is when we move forward, I'm trying to actually see what I'm looking at here. Sorry. We basically have two cells, but as you can see, one has both pairs of chromosomes and the other one has none. So as we continue moving forward, we see a proper cell division here going on where the basically pairs are split in half. So you have half of the X chromosome going on each side and the other half of the Y going on each side. But on our bottom cell, there's nothing. No chromosomes. So what happens is when we get to our final sets of zygotes, we have our top, which is, normal, or rather not too normal, but we have 4 zygotes, but 2 of them don't have any chromosomes in it, which is a major issue. Now that's going to happen that's a meiosis 1 non-disjunction. So now we're going to move on to meiosis 2. So let me flip this over, and we're going to do the same process. So starting out in our beginner cell. So it's pretty much the exact same thing, both lined up along the metaphase plate, spindle fibers connected to the X and Y chromosomes. So as we move along, sorry for all this shifting. So as we move along, we see our X and Y chromosomes properly split and go on each side of the cell. X going on one side, Y going on the other. And then as we move, we see a proper split. So now we have our X chromosome pair in 1 and our Y chromosome pair in 2. So of course there's switching going on, but we're just using the colors, because there's changes happening when it comes to the actual chromosomes crossing over. But we're just going to use the specific colors to help demonstrate a little easier. So as you can see, we have our X and Y chromosomes, which have been properly split, and which of course we need to do our second cell division. So they're lined up along the metaphase plate again, along the center. I know our X chromosome top is a little off. My apologies for that. But as you can see, when we move upwards here, there's a bit of an issue. So what's going on here? So on the bottom cell, it's actually pretty normal. We have our Y chromosome, which is being split in 2. Of course, it's been crossed over and mixed together with our X chromosome prior. So it does have some change going on there, but not proper because of the incorrect split that went on. So up top here, what's going on is our X chromosome is basically having a non-disjunction. It's failing to split properly here. It's not splitting in half with this cell, and the whole X chromosome is going onto the top part of the cell while the bottom is left with none. So when we move on to our zygotes for this, basically for non-disjunction in meiosis 2, we have our top cell, which has a pair of X chromosomes. This cell has no chromosomes, and this one has 1 Y each. So that's basically the way in which non-disjunction is going to occur. It's going to happen in that anaphase section of meiosis 1 and meiosis 2. It'll happen in mitosis, of course, as stated prior, but not to the same extent and occurrence as does it in meiosis. So that's my general understanding and overview of aneuploidies and non-disjunction. So thank you so much for watching and listening. Have a great day. Thank you.